Okay guys, we'll have a little look at the cofactor now. We've just done the 3x3 determinant, and the cofactor is just it's similar to this in terms of methodologies, but there's a lot more involved working out the cofactor matrix. This is the most difficult part of the problem. So we'll take a 3x3 example and we'll work out the cofactor, and it's best explained by examples, so I'll just show you here. So let's take this example of a matrix A here, and I'm going to write the cofactor matrix, so I'll write a capital C. Now basically what you do is you draw a template, and I've drawn it in yellow here. You do plus, minus, plus, minus, plus, minus, plus, minus, plus, and that should be familiar to you by now, right, for the 3x3. And then you just draw rectangular lines to just put in your associated minors. We did that with the determinant, didn't we? Part of this was the determinant, wasn't it, in row 1? There we go. So just do that. So we've got these yellow lines then. Now, how do we get these elements? Well, basically, these are the associated minors. The 2x2 is associated with the element 1. Row and column containing 1, you get 3, 1, 6, minus 2, which goes there. Then the next one, cross out the row and column containing minus 4, and you get 2, 1, 4, minus 2. Oh, we needed to do that when we did the determinant, didn't we? In terms of the method. And then the 7, cross out those, the row and column containing the minus 7, 2, 3, 4, 6, and you put it in there. Then we've got this one, which is this element here, row and column. You're left with minus 4, minus 7, 6, minus 2. And then the middle one, row and column, and you're just left with the 4 corner elements, 1, minus 7, 4, minus 2. And then the next one, here, you're left with row and column goes 1, minus 4, 4, 6. Put them in. And then the bottom row, this entry here, row and column, you're left with minus 4, minus 7, 3, 1. Here, you're left with 1, minus 7, 2, 1, aren't you, if you cross out that row and column. And then the last entry, row and column here, you're just left with these 4, 1, minus 4, 2, 3. Now it's just a matter of calculations then, isn't it? So for example, I've just done the first row here to illustrate it. Minus 6, leading diagonal product take trailing. Minus 6 take 6 is minus 12. Plus and a minus is a minus, so we can write minus 12 here. Then we have minus 4. Take away take away 4, which is minus 8. Minus minus 8 will give us plus 8. And then 12. Take 12 is 0. Plus 0 is 0. There we go. And you can do any other element if you wish. So let's just do one here. Let's do this one, for example. So that would be this element here. Let's just work that out. 6, take away minus 16, yeah? Which is plus 16. So 6 plus 16 is 22. Minus the 22 is minus 22. So you'd write 22, sorry about the mess, with a minus, yeah? And if you can read that, you've done well. Minus 22. Okay? So that's the cofactor matrix then, which we write here. And then basically I'll finish off the intros here because everything else follows from this now. The adjoint, which we write as Rj, which is the next piece of the jigsaw. So we've done the cofactor now. Then it's just the adjoint and the inverse are very simple, so I'll just mention them now, I think. So we've got our cofactor matrix, which was the difficult problem. And then the adjoint is just C transpose. And we've done transposition before, transposing matrices. So you just transpose this to get CT, change the rows to columns. First row becomes the first column, second row becomes the second column, third row becomes the third column. There's your C transpose in your mind's eye then, and that's called the adjoint. And then simply the inverse, you just need to divide the adjoint by 1 over det A, and you obtain the inverse matrix. And this is the property of the inverse here. When you times it by A, and A times the inverse both ways around, it will equal the identity matrix in the 3x3 case here, of course. And but the point is, you cannot get an inverse if this is 0, can you? Because you can't divide by 0. So that's why we call it the determinant, because it determines whether we can proceed to find the inverse and whether the inverse exists. Okay then? So that finishes the little intros for the remainder of this section, and hope you get on okay with them, and I'll catch you again. Cheers!